sample spaces, events, and probability. So just take a minute to read these definitions, get a good understanding on them, and let's move on. Solving example 1. Without using our calculator, we're just determining if event E or event F is more likely to occur. We're basically comparing the two events. And if you notice, the event E is in decimal form already. The event F is in fraction form. Now, some people automatically knows by looking at the fraction knows, but if you're not seeing it, we can do long division. The bottom denominator, the bottom number, which is the denominator, goes on the outside, and then the numerator, which is top number, goes on the inside. And we say, does 7 go into 10? Or excuse me, go into 1? We're going to say no. So I'm going to add a decimal and a 0. Now I can say 7 goes into 10. I can say it goes into it once. I like to put a 0 in front of that decimal just so I can see the decimal. 7 goes into 10 once. So I'm going to subtract. 1 times 7 gives me 7. 10 minus 7 is 3. Bring down a 0 because I didn't get a remainder of 0. 7 goes into 30 4 times. 7 times 4 is 28. 30 minus 28 is 2. Bring down the 0. And 7 goes into 20 2 times. I'm going to stop here. And the reason why I'm stopping here is because the event E is already in hundreds. So let's round this to the nearest hundred. So that means I need to look at the thousands, which is the 2. And you ask yourself, is it equal to or greater than 5? You say no. So we're just going to drop it off. Our answer is going to be 0.14. And if you compare these two, you notice event E is greater than event F. So we're going to say that event E is more likely to occur. Example 2. A circular spinner is divided into 19 sectors, and they are equal area. We have a red sectors, a blue sectors, a yellow sector, and a green. And as you see here, it says we have 7 reds, 2 blues, 6 yellows, 4 greens. And it says, consider the experiment of the spinning spinner once. We're going to find the probability that the spinner lands on blue. And if you notice, the event is talking about the blue. So, and it says here that it has 2. The number of sample here is the total, which is 19. So when I find the probability that this event will happen, it's going to be 2/19. And leave it in fraction form unless you are asked to round to a specific decimal placement. Example 3. A cooler at a picnic contains 100 cans of soda covered by ice. It says we have 43 colas, 22 orange sodas, 33 ginger ales, 2 cans of root beer. The cans are all the same size and shape. If you pull one can out at random, what's the probability that it'll either be root beer, ginger ale, or cola? So let's go ahead and state what our sample size is. We know that the number of elements in the sample is 100. Okay, now let's figure out the event. Well, the event says we want root beer, so they said there was 2 root beers plus the ginger ale. The ginger ale is 33 plus the cola, which is 43. When we add these up, we get 78. Now let's find that probability that event will occur. We have 78 100ths. All right, if you can reduce, always reduce. And I notice it reduces by 2. 2 goes in 78 39 times. 2 goes in 150. This does not reduce no further. The probability of this event occurring is 39/50. Okay, so let's go to example 4. A card is drawn from a well-shaped deck of 52 cards. The probability that the card is a spade or a 10. So what is that probability? Well, let's look at it. There are 13 spades in a deck, right? There is 4 10s in a deck. However, one of these 10s is in that 13 because we got 2, 3, ... to 10, then Jack, Queen, king, ace, right? So I'm gonna subtract 1, and then I'm gonna say there's 3 10s, because 1's already been counted in that spade. So now I'm going to take the event, and I'm gonna say 13 plus 3 gives me 16. And then my number of elements in that sample is going to be 52. So that probability of this event happening is 16 52s. However, I noticed this reduces by 4. 4 goes in 16 4 times, goes into 52 13 times. So that probability is 4 13s. Example 5, suppose that 9 thank you notes are written and 9 envelopes are addressed. Accidentally, the notes are randomly inserted into the envelopes and mailed without checking the addresses. So what is the probability that all the notes will be inserted into the correct envelope? So let's look at this. The sample size of this said that we had 9 envelopes and 9 letters, and we put the letters in those 9 envelopes. So I'm gonna have 9 factorial. That's gonna be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which gives me 3 6 2 8 8 0. And what is that? That's number of elements in this event. The probability of it happening, that we're going to figure it out. This event is 1. 1 time, we're seeing if it's going to be correct. So the probability of this event happening is 1 per 3 6 2 8 8 0. And when we type that in the calculator, and I'm going to round to that number, it's going to be a small probability that all of them are correct. Example 6 says an experiment consists of rolling 2 fair dice and adding the dots together. So when you roll the dice and you got 2 of them, the dots that are facing up, we're going to add together to see if it gives us a sum. And this one here, it wanted to know what's the probability that the sum will give you 25. Okay, so the chart's already been drawn out for you here. You have dice 1 or die 1, and it goes 1 through 6. Die 2, it goes 1 through 6. So you can roll the 2 die and get, there are 2 dice and you can get 1 1, or you can get 1 2, 2 1, and so on. Well, what if you're trying to do is roll those 2 dice and the sum of those dots showing up would be 25. Well, if you notice that that's not a possibility. So the number of elements in that event is 0. However, there is a number of elements in the sample, and then we notice that we have 6, right? 6 chances here on the die and 6 on the second one. So I'm going to say 6 times 6 is 36. Now that probability of that event happening is 0, 36. The answer is 0. So I'm going to do one more example just to make sure. What if you were asked that the sum gave us 8? So we're going to come back to this table here and we're going to look everywhere. And I noticed that I have 6 plus 2 here gives me 8. 5 plus 3 gives me 8. 4 plus 4 gives me 8. 3 plus 5 gives me 8. And 2 plus 6 gives me 8. And there is 5 of them here. So this probability of this event happening is going to be 536, and it don't reduce. So kind of get the idea. All right, so now let's do example 7. Membership selection. A town council has 19 members, 9 Democrats, and 10 Republicans. A asks us this: what if the president and vice president are selected at random? And what is the probability that they're both Democrats? So we're going to take the number of elements in the sample, and I got 19 members times the 2 groups times the 9 Democrats. I get 342. Okay, so now I look at this and I notice it's a permutation. So in order to find the number of elements in this event, I need to use the permutation formula. So I see, and I'm going to write it in a notation that you'll see, that I have 9 Democrats, comma, and I have 2 groups. That means my N, and let me do another step right. I just want to clarify the notation here. This is N comma R. So I'm going to have N factorial over N minus R factorial. So my 9 factorial over 9 minus 2 factorial gives me 9 over 7, 9 factorial over 7 factorial. I'm going to do one extra step. That's 9 times 8 times 7 factorial. And what happens? My 7 factorials reduce. And now I got 9 times H, which is 72. Now let's finish off. The last part here is I'm going to take the probability of this event happening. It's 72 over 342. Type it in calculator, you can do long division. I get 0.211 rounded to the nearest thousand, and that's that probability. So that was a permutation because we were talking about, you know, these president versus vice president. But look at part B. Part B says if a 3-person committee is selected, so we are talking about a combination. So that formula is going to change. Okay. However, we used a P up here. We're going to use a C. We're going to have N comma R. We have noticed this notation. So whenever you see this in the textbook, you may see this notation as NPR like this. Okay, so these are just written in a different format, but the same rule applies to them. All right, so now what we're going to do is find the probability the Republicans make up the majority. So let's set up what we know about our event and our sample, right? So our number of samples here, we're going back up to the top, 19 members, but we're in a 3-person committee now. So now I have 19 factorial over 3 factorial times 19 minus 3 factorial. And if you don't remember the formula, it's N factorial over R factorial times N minus R factorial. And this is for the combination. Okay, so when we type this in the calculator, I get a number. I'm going to go one step here just to show you the math. Okay, and I'm running out of paper room, so I was just going to type it in the calculator, but let's do this right quick. Let's just see what happens. Okay, so the 16 factorials reduce. And I notice I can break 18 down as 3 times 6, right? So, well, let me not skip that step. Hang on a second. I'm skipping a step thinking it was going to help, but yeah, I need one more step. So I have 19 times 18, which I'm going to break 18 down as 3 times 6. But 6 is 3 times 2, and then times that 17, all over 3 times 2 times 1. Now let's do what I was fixing to do. The one of the 3's on top reduces with the 3 on bottom, the 2. And now I have 19 times 3 times 17, right? So let's multiply that out. So 19 times 3 times 17 is 969. Okay, so now we have that, and I'm going to have to erase this. So I encourage you to write it or pause this so you can write it down. I just ran out of paper room, so let me write the answer right here. Okay, 969. So that was my sample, my number of elements in that sample. So now we're going to have 2 things going on here. We're going to have an event 1 where we have a 3-person committee And we have with 2 Republicans and 1 Democrat. And then we're going to have event 2 with 3 committees with 3 Republicans. Okay. So now we're going to find event 1. So I can write it as right here, the order. 1 is 2 Republicans out of 10 available. And if you look at the top, it's there was 10 total, right? I'm abbreviating because of the paper room. So my number, here we go. Let's do this. In 1 of C gives me 10 Republicans in 2 groups. Event E, 2, we have order 2. I said 1 Democrat out of 9 available. Okay. So now let's do the math on this. We have the number of events from our N1 times our N2 gives me C10(2) times C9(1). And I'm going to double check my math. But what it is we got to go back to our formula. We have 10 factorial over 2 factorial times that 10 minus 2 all factorial. And you got 2 options. You can write that answer down, which is 45. And we're going to multiply it by the next fraction. I have 9 factorial over 1 factorial times that 9 minus 1 factorial. And it gives me 9. So now we have what? 45 times 9 is 405. Okay. So now we know what the event 1 is. Oh, and I should have put event 1 right here. Now let's look at the number of elements in event 2. So what we're going to do is have C10, 3. And that is our, go back to, I have it written down. Oh, that is our total Republicans and our 3-person committee. So we're going to do it the same way. We're going to use this formula. And this is the formula I'm using to find the answers on this part. So I got 10 factorial over 3 factorial times that 10 minus 3 factorial. That gives me 120. Okay, so almost done, guys. Thank you for hanging in there. So now I'm going to take the number of elements in that event, and I'm going to add the event 1 plus the event 2. So I got 405 plus 120 is equal to 525. Last step now. Now that probability of this event happening is going to be, remember, this is our formula, the event over the number of elements in that event over the number of elements in that sample. We got 525 divided by our 969. And I'm going to round to the nearest 10 or thousands. Let's just round to the nearest thousands. And this is the probability.